All right, so I just learned that Screencastify limits my video length and my video length under this particular light version. So we're going to add this to the playlist and just keep going. Keep that in mind. So we're left with trying these problems here. So the cubed root of 125, cubed root of 8. If you want to pause the video and figure those out, you certainly can. Cube root of 125, what times itself 3 times is 125? Well, we actually have that up on our chart here. 5 times itself 3 times is 125. 5 times 5 times 5 is 125, which means that 5 is the cubed root of 125. What times itself 3 times is 8? That's also up on our chart here. If we look at this row right here, what times itself 3 times is 8? 2 times itself 3 times is 8. So the cubed root of 8 is 2 because 2 times itself 3 times is equal to 8. Up on the chart, we could also figure out the cubed root of 64. What times itself 3 times is 64? 4 times itself 3 times is 64. And then what times itself 3 times is 15? Well, once again, 2 times itself 3 times is 8. 3 times itself 3 times is 27. So this is going to be between 2 and 3 then. 2 times itself 3 times 8, and 27. So somewhere between 2 and 3, more like maybe close to halfway between 2 and 3. And if we were going to take a look at that on our graphing calculators and some of the other calculators, a cubed root is actually not a button that we see here, but if you go into the math menu right here, you'll notice that the 4th one down here is the cubed root. So you can select that, and in this case, we're going to do the cubed root of 15, and we can see it's, about halfway. If we round to the 10th place, it would be 2.5, so 2.47 approximately. But between 2 and 3 for sure. All right, how about these other ones here? Notice that now we have a 4. So what times itself 4 times is going to be 81. Let's see if we have that on the chart here. So this is called the 4th root. So what times itself 4 times? So we're looking at this row right here for these numbers. What times itself 4 times is 81. 3 times itself 4 times is 81. So the 4th root of 81 is 3, because 3 times itself 4 times is 81. What times itself, notice this is the 5th root. What times itself 5 times is 243? Do we have that on our chart here? What times itself 5 times is 243? We have 3 times itself 5 times is 243. So the 5th root of 243 is 3, because 3 times itself 5 times is 243. Now notice these last two actually don't have special buttons on our calculator in the math menu, but that doesn't mean we can't do it. It's actually this one right here that you could use, and I'm going to show you a couple ways of doing that. I'm just going to try to remember how this goes here. So if we do, okay, so it brings that up first. So if you want to do the 4th root, say, let's use a right arrow of 81. That's how you would type that in, and there's that 4th root of 81, which was 3. We can come back to that in a little bit. So the 6th root of 64. Well, do we have the 6th root out? That we did. So the 6th root would be what times itself 6 times is 64, and we do have that up on our chart here. 2 times itself 6 times is 64. 2 times itself 6 times is 64. And then finally, 121. Now, I don't think that's on our chart, but notice it's no longer a 5th root or a 4th root or a 3rd root. This is actually just a plain old square root. Do you know what times itself twice then, since it's a square root? By the way, square roots don't normally write the little 2 in there, but there is a little imaginary 2 in that little slot here to identify that it is a square root. But we use square roots so often that we don't put the little 2 in there. We just know that that is there. It's kind of like we don't put a 1 in front of the x when we say, like, solving an equation x equals 5. 1 times x is just x. So we just say x is equal to 5. Well, what is the square root of 121? You might know that 11 times itself is 121. So 11 times itself 2 times is 121. All right, let's move on to the second side of our notes here and talk about another way of actually showing these different types of roots. So square roots and cube roots and nth roots would just be indicating whatever type of root you want, a 6th root or a 100th root if you wanted to. What times itself 100 times would be that number. Not something we have to figure out very often. But you could do that. You could also do this with using rational exponents. Now, a rational number is a fraction. Okay? It's a number that you can state as a fraction. There are numbers that you cannot state as fractions. The most famous one that we'll talk about in a couple months is pi, the mathematical constant pi, 3.1415, et cetera, et cetera, et cetera, the ratio between the circumference and the diameter of a circle. But that number cannot be stated as a fraction. Rational numbers are numbers that can be stated as fractions, and therefore 1/4 is a rational number. If you had the decimal 0.25, 25 hundredths, you could reduce it to a fraction of 1/4, and essentially 25 hundredths is a fraction also. So this is another way of saying when you take something to the 1/4 power, that's the same thing as saying the 4th root. So it's like saying the 4th root of 81. So the reason why this is nice is because oftentimes calculators can calculate powers a little bit more easily than the roots. So like, for instance, our calculator here, the graphing calculator, if we wanted to do 81 to the power of 1/4, just use the little power button here. So notice this power button. And then, I usually like to use parentheses, although I think in this case we could do 1/4 by just taking 1 divided by 4 and we'll keep it all as an exponent. So again, I just did 1 divided by 4 to create that fraction 1/4 up there. And so notice that that is the same answer as our previous one here. So the 4th root is the same thing as 81 to the power of 1/4. Okay, so we can use that idea, which, by the way, was 3, you saw that. So 243 to the 5th power is the same thing as the 5th root of 243. So 243, what times itself 5 times is 243. So 243 to the power of 1 divided by 5, the power of 1/5. What times itself 5 times is 243. Well, there's that number 3 again. We've seen that a few times. What times itself 6 times? So this is the same thing as taking the 6th root of 64. So you might just remember that one, that 2 times itself 6 times was 64. So if you want to punch that into your calculator, you certainly can. But 2 times itself, 2 to the power, 64 to the power of 1/6 is 2. And conversely, 2 to the power of 6 is 64. So if you want to reverse that. And here we go, 1/2. Remember, 121 to the 1/2 power. That's the same thing as saying the square root of 121. And normally, we don't have to write the little 2 here if we don't want to. And by the way, the exponent here comes from the number underneath the root being raised to that numerator power, and then the root is the denominator of that. So 64 to the 1/6 is the same thing as the 6th root of 64 to the 1. So that's where those 2 numbers actually come from. We just don't tend to write in that power of 1. So the square root of 121 to the 1/2 power. And by the way, if you want to do that, you can. 121 to the power of 1/2 is the same thing as the square root of 121. So the square root one, if you wanted to use that, square root of 121, notice, is the same thing.